All right, we are on to video number 2. Video number 2. I'm not sure why they make a pen like that, but they do. All right, so electron configuration. Electron configuration, what is it? It's the configuration of electrons, right? How those electrons are arranged within the atom. So we've talked about S, P, D, and F. 1, 2, 3, 4, 5, 6, right? Those principal quantum numbers, the orbitals, the sublevels. So electrons will arrange themselves to have the lowest possible energy, right? So in their ground state, they're going to feel the lowest energy first and then get higher, okay? So they want to be the most stable. All right, so we have some rules. We have our Hund's rule, which the most stable arrangement is the one with the greatest unpaired spins, right? So we looked at that in the other video. They're going to fill up singly before they start to pair up. Why? Well, they're both negatively charged, right? They're going to repel each other, so they're going to be as far away as possible, okay? Make sense? Good. The other one, the Pauli exclusion principle. So that is saying that only electrons will have opposite spins when they're in the same orbital, the same box when you draw them, okay? So one will be spinning clockwise and the other one will be spinning counterclockwise. If you do a little bit of research and tell me a little bit more information behind that, I will give you a few bonus points. All right, so when you draw them in the box, single first, and then they pair up. Remember, it doesn't matter if we're in like a 2p, it doesn't matter which p they go in, first or second, because they're all the same level. All these p sublevels, all these p orbitals will have the same energy. They're all in the 2p. All right, so off-balls diagram. Memorize this. It's pretty easy. I usually just remember, I just start and write. I don't know if I start from the bottom or the top. It doesn't matter. However you want to remember it, you can see these are both two different ways. So the off-ball diagram, it just shows us from highest to lowest energy, and the principle just states that they're going to fill lowest first. So however you want to start, if you want to start 1s at the top, then 2s, 2p. Remember, when we have 2, we can have 2 different sublevels, s and p. When we have a 3, we can have 3 different sublevels, S, P, and D, okay, etc. So you just keep writing. And then this fill. So we'll go 1s, then we fill 2s, 2p, 3s, 3p, 4s, 3d. 3d is higher energy than 4s. Okay, so this is an easy way. You just remember how to draw the chart. You start to take the test, you draw the chart real quick, and then you can follow along the chart when you're doing your electron configuration stuff. Okay, here's a nice visual of energy. So energy is increasing as we're going up here. So 1s, 2s, 2p, 3s, 3p, 4s, 4d. So remember, 4d is higher energy than 4s. And this is a good visual. 1 can have 1 sublevel, 2 can have 2, 3 can have 3, 4 can have 4. All right, things to remember. They'll always fill up the lowest energy levels first. They will always fill up single first, and then they will pair up. 3 different ways to write them. You have to know vocab, right? You have to know terms, definitions. So electron configuration, when we ask for that, that would be like 1s2, 2s2, 2p6, 3s2, etc. Orbital box diagrams would be drawing the boxes. These boxes represent like the orbital, but we would say 1s, 2s, 2p. Then the electrons are in the boxes. So we wouldn't write 1s2 there. That 2 is represented, those electrons are represented by arrows. Oh, that was bad. Did you see what I did wrong there? I filled it up twice first. Okay, so that's orbital box. And then noble gas configuration. We'd have like the noble gas in brackets. So this means that takes care of 18 electrons. So then we'd start after argon, which would be like 4s whatever. So 4s2, so that would be calcium. Okay, so you have to know the difference between those. When we're talking just the electron configuration, principal quantum number, sublevel, and number of electrons in that sublevel, in that orbital. All right, let's practice a few. If you've watched the recording, you probably have seen some of these. So let me make up some new ones. Let's do iron. So look at iron on your periodic table. First thing you ask yourself, how many electrons are there? There are 26 electrons. So we're going to write the electron configuration first. So pause it, write your off-ball diagram, figure out where we start. 1s, 2, 2s, 2, 2p, 6, 3s, 2, 3p, 6, 4s, 2, 3d, what? So we have 6, 7, 8, 9, 10, 16, 17, 18, 19, 20, 3d, 6. So at this point, you double check yourself. I wish I had a... So double check yourself by counting your electrons. Make sure you have 26 placed. Since you have watched or going to watch the shortcut configuration on the periodic table, if I look at my D sublevel and I look at 3D and I go over 6, I should land on iron, and I do. And let me show you what I mean there since we're talking about it. Okay, so here is my periodic table, and if you have not watched this shortcut yet, you need to. This is where the periodic table is just beautiful. Okay, so S, remember S we said can hold 2 electrons because it has 1 orbital. So here is our S sublevel. Remember P, P's have 3 orbitals, each can hold 2 electrons, so 6 electrons total. Here is our P sublevel. D has 5 orbitals, 2 each, 10 electrons total. And then F's have 7, and they can hold 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What you do have to watch is different periodic tables will look a little bit different. So some of them might actually put this like CE, like these extra ones in here. So you just have to make sure you're starting at the next one. If that makes sense. So what we have is we have, let me change my color again. Okay, so for our S, remember, we start with 1, and I just label right down here. So here is 1s, here is 2s, 3s's, 4s, 5s, 6s, etc. Remember P, S, P, D, F. So P's don't start until 2. So this is 2p, 3p, 4p, 5p, 6p. D's don't start until 3. So here starts 3D, 4D, 5D, 6D. And F doesn't start until 4. So 4F and then 5F. I don't have that down there. 4F and 5F. Okay. So here's your shortcut. What you are able to do, let's say I give you palladium, which is right here, 46. By just looking at this periodic table, I can tell that it should end, just at least end in 4, because here's my 4, D 1, 2, 3, 4, 5, 6, 7, 8. It should end in 4D8. Okay, so it's just a double check. Did I end in 48? If I forget my off-ball diagram, all I have to do is look at this and I can tell, I can see, let me see this. I can see that we start here. Let me find my pen again. Start 1S, 1S1, 1S2. Then we go to 2S. 2S2 is full, right? Then 2P, 2P6, full. 3S, 3S2 is full. 3P, 3P6 is full. 4S, 4S2 is full. Then we start at 3D, 3D 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. 1, 2, 3, 4. Should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3D10 is full. 4SP, 4P6 is full. 5S2 is full, and then I'm at 4D, and I stop at 8. So this shortcut, I call it a shortcut. Once you know what this periodic table has and does for you, you can do any electron configuration possible. Okay, so we're back up here. Let's look at orbital box diagram because we're running out of time here. And where's my pen? And let's see, keyword will be, keyword is thankful. So that's our chemistry check. Connect and check. Keyword, thankful. All right. So, orbital box diagram. Let's not do aluminum. Let's do nitrogen. Okay, nitrogen has 7 electrons. So, we will start with 1s. We draw our box. Electrons. 2s. Draw our box. Electrons. I only draw one side. It doesn't matter if you draw your electrons like this or like this. Doesn't matter. I just do a single arrow. Don't ask me why. I think in college we got lazy drawing them all the time. Okay, so now we have 4 placed, 2p. So 4, 5, 6, 7. We are done. Remember, if you put 1s2, that is incorrect. All right, last one, noble gas configuration shortcut. So you use the shortcut because it just cuts down on having to write 1s2, 2s2, 2p6, etc. Right? So let's go ahead and let's look at the example. Let's look at the example iodine. So if you look at iodine, it has 53 electrons. So what you need to do is you need to find the noble gas closest to but not over that. So if you look at your periodic table, iodine is actually right here. So we're going to use krypton. So when we put krypton in brackets, that represents all 36 electrons. This is where that shortcut for the periodic table comes into play. Because look here, here's krypton. So to figure out where we start, well, it's very easy. We're at 5s. So we'll go 5s2, 4d10, 5p5. So krypton, 4s, 1, 2, 3, 4, 5. 5s, 2, 4p, 10, and then 2, 3, 4, 5, d, 5. So double check and add them up. Krypton was 36, 46, 47, 48, 49, 50, 52, 53. Check. And I'm done. All right, so you need to be able to do all 3 different types, okay? We're about out of time. Make sure you guys have taken the time to watch those videos. Do your practice. This all takes time, right? The only way you're going to learn this stuff is to practice, practice, practice. All right, I'm excited that we got these in. All right, talk to you soon. Bye, guys.